Saturation and humidity. So our atmosphere holds water, and the ideas of saturation and humidity are related to how much water is in the atmosphere. So let's look at these two concepts separately. Starting with saturation. If you think about something being saturated, it's essentially full. So when the air is saturated, it can't hold any more water, which means that if more water evaporates, some water must leave the air. So if you think about a glass of water and it's full, and then you add some water to it. Well, of course, what's going to happen? Some of that water spills out. So the same thing happens to our air when it's saturated. If, the heat rises, some water evaporates, that water is going to push other water out. And so in this case, water spilling out basically means condensation. So it couldn't be dew forming on leaves. It could mean the formation of clouds. All of these are ways of that saturated air condensing water out as more water is added to it. Now, humidity has to do with levels of water in the air as well. And it turns out there's two ways to measure humidity. So one way is called absolute humidity. And this is one that you don't normally hear when you listen to the weather forecast. This is the number of grams of water per volume. So if you picture our cup of water, how many grams in this cup, where that cup is our volume. So, typically, Mr. Weatherman is going to not be telling you, today our air is holding 10 grams of water per cubic meter. You don't hear that too often. What you normally hear is relative humidity. So relative humidity is how much water is there compared to how much water would it take to saturate the air. So you have this idea of saturation, and of course saturation is going to be 100% humidity. And so anything less than saturated is going to be less than 100% relative humidity. Now there's a couple things that are going to play a role. One, the warmer air is, I'm going to say the warmer the air, the the more water it can hold. So if I continue in my cup analogy, cold air is going to be a small cup. Warm air is a large cup. And that's because of the fact that cold air shrinks. So you have less volume. Warm air expands. So you have more volume, more room to hold that water. So that's our first important effect. So then we have different combinations. For cold air, then we can picture that as a tiny cup. So not much water is going to get you 100% relative humidity. Warm air is our larger cup. Same amount of water is going to be a low humidity. So if we think in terms of, okay, this cup is full, I'm going to have orange water. That same volume over here, something about like that, that's pretty low humidity. That might be 25% humidity. So as air gets warmer, if no water is added, relative humidity decreases. And then, of course, the reverse is also true. As air gets cooler, relative humidity would increase. Now, in both cases, the important caveat is if no water is added. Of course, if you have more and more evaporation occurring, that's going to add more and more water to the air. So this is based purely on this concept that the amount of water is fixed, and the only thing we're changing is the temperature of the air. So that is humidity. And once you get to 100%, then you've got saturation as well.